Hi, welcome back to CMG Math series. Continuing with our series on AKI-OLA core math, this is part 5, right? And in this part, we are still on the topic sets and operations on sets, right? In this episode or part, we are dealing with special sets of numbers, right? So we dealt with the types of numbers, the types of sets, and then the set notations. They are special way of representing these in writing or in calculation, right? So where we are now, we are dealing with special sets of numbers. Now there are some sets which hold great mathematical importance and are referred to with such regularity, right? Such regularity that they have acquired special names and notational conventions to identify them. So there's a special way to represent this, else you wouldn't get that. So now, when solving some problems under a set of numbers, the following special sets of numbers must be known. Now let's begin with natural numbers or counting numbers. Right. We are saying that the set of natural numbers or counting numbers is 1, 2, 3, 4, 5 up to infinity, or yes, infinity. So we can see the dot there, or the ellipses there. So we can count up to we get tired, and they begin with what? 1. So naturally, when you are counting number, or you have been asked to count a number, you don't begin from 0. Naturally, you begin from 1. So that's why we are saying natural or counting numbers start from 1, and they are denoted with the capital letter or the symbol as n. That is as simple as that. Now when you move to whole numbers start from 0. Whole. So I'm giving you special way, simple steps to remember this. We are not only focused on teaching you, and then when you close the book, you forget everything. So we are giving you images, right? So that is it. So we have whole numbers starting from 0, right? Whole numbers, something like this, whole, starting from 0. So, and then the symbol is capital W. Whole numbers, capital W, starting from 0, right? You keep counting. Now we move to odd numbers. Then the odd numbers, right? Now the set of odd numbers is a set whose members cannot be divided by 2 to get a whole number. So it cannot be divided by 2. When anytime you divide it by 2, there will be a remainder or a fraction. And anytime you do and you get something of that sort, that is an odd number. So it's as simple as that. Now, when you move to even numbers is a set whose members can be divided, right? A set of even numbers is members that can be divided by 2 exactly. So we are jumping 2 steps ahead, hopping by 2. The even numbers we jump by 1, right? Even numbers we jump by 1. So from 1, instead of going to 2, move to 3. So just a step, a jump. Then when you move to even numbers, twice, right? So 2, 4, 6, 8, and that's begin with 2. Even numbers begin with 2, odd numbers with 1. In that step, it's as simple as that. Now let's move to prime numbers or factors, right? The set of prime numbers or factors is a set whose members are prime numbers, right? That is, each member has no other factors except itself and 1. Now let me demonstrate this with in an easy way. Let's move here. I know everybody knows this. In our elementary class, we were forced to learn the times table: 2 times 2, 3 times 3, 4 times 3, and so on and so forth. Now, anytime you multiply, let's say multiples of 2, right? That's the timetable, 2 times table. When you say multiples of 2, that means the 2 times table. Multiples of 3 is the 3 times table. That is as simple as that. So the numbers here, right, on the right side are the multiples. The multiples of these. And then these ones, the 2 or any of the numbers that you multiply to get the products or to get the number. Like, I don't want to be using the terms so that I confuse you. So The numbers that we multiply to get this number on the right side are called the factors. Right, are called the factors, and these are the multiples. Right, and now we are dealing with what? Prime numbers. Right, so it is out of the prime numbers. Sorry, it's out of the factors. After these factors, that we get what? The prime numbers. Now, what is a prime number once again? It said it's a set whose members are prime numbers. That is, each member, right, has no other factors except itself. So if I take 2, for instance, 2 like this, 2, what are the factors or numbers that when I multiply I'll get 2? I can get 1, I can get 2 itself, then that will give me 2. So it means that I can't get any other factors except 1 and 2 to get 2. Right. The same thing for 3 will give me this. It's only 1 and 3. If I take 4, that will be wrong, because 4 I'll have more than 2 factors, because 2 by 2 will give me 4. Now 1 by 4 itself will give me what? 4. So that makes this 4 not what? A prime number. Right. So the prime numbers basically, they start from 2, 3, 5, 7, 11, 13. 15 does not count, because 15 I can get 3 by 5 to give me 15. Now I can get 1 by 15 itself to give me this, and this is more than 2 factors. That's 1 and 15 itself. So besides this 1 and 15 itself, I'll still have this. So that disqualifies it. Right. So that is as simple as that. If you having any difficulty understanding this, hit me in the comments and I'll attend to you separately. So that is it. So I've used this to explain this. So now let's go back to where did we get to? So we have dealt with what? Prime numbers, right? That's 2, 3, 5, 7, 11, 13. Then we have the multiples. So I think I've explained the multiples. The multiples of a number. The multiples of a number here, we have what? 2. So when I say multiple, I've said that already, earlier. So multiples of 2, that means the 2 times table. Right? So these are the multiples. Right? The number itself times 1, 2, 3, 4, 5, 6 coming down. That's what the multiples of that. The number itself. So you see that 2 is appearing. So the number itself, which is 2, and the multiply in that sequential order 1, 2, 3, 4, 5, 6, 7. So that is it to get this. So that is as simple as that. Let me once again read so that I get a point. So the multiples of x are numbers obtained by multiplying x. So in our case 2 or 3 by 1, 2, 3, 4, 5, etc. For example, the multiples of 3 are 3, 6, 9, 12, 15, etc. Also, the multiples of 2 are 2, 4, 6, 8, 10. It's as simple as that. Now, integers. What are integers? The set of integers is a set of positive and negative whole numbers. Negative whole numbers. So, the negative whole numbers and then the positive whole numbers. Now, the only inclusion is 0. So, you get it. So, you have to include 0 to get what? Your integers, right? Without 0, it's not integer. So, that is what you mean. Now, the last but not least is what? The square of numbers, right? So the set of square numbers are numbers obtained by multiplying 1, 2, 3, 4, 5, 6, etc. That is, the set of square numbers is 1, 4, 9, 16, 25, 36, 49 in that order. So we are just squaring the numbers up. So any number that you are given, you square them up. So if you are asked to give me the square of 25, that would the square of 5, sorry, is what? 25, right? Square of 7 is 49. In that order, it's as simple as that. So we will see you in the next one. Stay blessed, like, share. Bye for now.